Hi children, this is your physical science facilitator SS from Command Group of Schools. Welcome to the online classes. In the last class, we learned how to prepare a base and one chemical property of acid, that what happens when the metals are reacted with acids. Of course, hydrogen gas is evolved. In that, better to write in the last one as the equation. I wrote at the top now. So, give you a subheading after conclusion as the equation. There you will write that one. And today we are going to know something about another physical property, some other physical properties of acids and bases, and one more indicator. Right, we will see. And children, are you observing or not? I don't know. Daily we are reading one problem. Daily one problem regarding coming with related to science. In first day, regarding magnetic, sulfuric, organic. In second day, sound, light, current. Now, education is equal to memory into concentration square. Concentration square, memory is less, concentration is more. So, whenever you are doing your work, concentration will play a vital role. So, we should be focused on concentration. Okay, right. Now let us see one more chemical property as yesterday that what we learned. Now if you see, metals react with acids. Then what happened? Salt and hydrogen gas is evolved. So when metals react with acids, hydrogen gas is evolved. What happens when the bases are react with the metals? Means when these metals are going to react with the bases, then what happens? Here, only few bases will react with metals. Only few bases. The two concentrated, more strength bases. Means strong bases, concentrated bases, excess of bases with metals. And one more thing, directly they won't react. If you see in the previous class, metals directly react with acids and form salts and water. Simply we add the both, just we add the both. But here, when bases, what type of bases? Strong bases. The two excess of base, with whom? Metals. Directly they won't react. We have to heat. We have to heat. It is the symbol for heat. So when you heat, then the strong bases may react with the metals. So it is clear that all the bases does not react with metals. Okay. Strong bases, the two excess of base have to be considered. They will react with metal on heating only, on heating. Then they produce, of course, salt, the respect to salt, and liberate hydrogen gas. So here some differences are there. Let us say about the metals react with acids. Metals react with acids directly. It is a fast reaction. Salt will form and hydrogen gas is evolved. But here all the bases does not react with metals. Only strong bases will react. The two excess of base react with metals on heating only, on heating. Then salt will form besides the evolution of hydrogen gas. Let us see about that. What are the examples we are having? Zinc is a metal, and of course strong base. Strong base, NaOH is a strong base on heating. Then it will produce one salt. This is called as sodium zincate. Sodium zincate is salt, and besides this, hydrogen gas is evolved. Hydrogen gas is evolved. Okay, for this also the same procedure. Same procedure. Of course, here you see how many sodiums are there? 2 sodium. Here only 1 sodium is there. Just to balance that, keep 2. Means excess of sodium. 1 zinc 2 moles, 1 mole of 2 moles of sodium hydroxide means excess of, what is this one? Strong base. Excess of strong base react with metal on heating, produce salt and evolution of hydrogen. Don't forget, all the bases does not react with metals. Okay. If you want to explain all this, same thing we have to take one previous one. What do you call this? Boiling tube. In this boiling tube, some zinc granules. Some zinc granules you have to be considered. And have to add NaOH base. It's about NaOH base. It's about zinc granules. It's about NaOH. Okay. So similarly, let's close with the monohydrate number stopper. In this one, delivery tube. And of course, this delivery tube has kept a drum which consists of soap solution. But directly the reaction does not take place. For that, it is spirit lamp or maybe the Bunsen burner, heat it. After heating, the strong base will react with the zinc granules and hydrogen gas is evolved. And when a burning splitter is introduced here, it will be put some with a pop salt. Put some with a pop salt. So we can identify the gas which is released here is hydrogen gas. But this reaction may not applicable for all the bases. Only strong bases, excess of bases will react with metals only on heating. But metals directly react with acids. Salt and hydrogen is evolved. Okay, so it is an exothermic reaction in the previous this one. When metals react with acids, immediately hydrogen gas is evolved. That is an exothermic reaction. It is evolved. But here we are heating. We are heating in the case of bases. In the case of acids, heat is releasing. So heat is releasing means what type of reaction it is? Yes, exothermic reactions. Okay. Now, are you following? All of you have the textbooks? No? Yes. Now, very important, one more important activity, that is about what happens when carbonates or bicarbonates of metals react with acids. Let us see about that. First, we should know what is the word carbonates. Okay, carbonate or bicarbonate. Of whom? Of metals. That is the question given. First of all, we should know what is meant by a carbonate. Whenever there is CO3, we call carbonate. Carbonate. Whose carbonate? Metal carbonate. Take a metal. Sodium carbonate. But what is the valence of sodium? 1. Carbonate valence is 2. So, Na2CO3. Sodium carbonate. CO3 means carbonate. Metal carbonate. Sodium carbonate. If I want to take CO3, I will write calcium here. Calcium is a metal. Calcium and CO3 means carbonate. Calcium carbonate. Not copper 3. Calcium carbonate. Right. Next. Like that you may write magnesium carbonate, zinc carbonate, iron carbonate, like that so many. Whenever CO3 is there, carbonate. In front of that metal, what is the metal? Sodium, magnesium, calcium, iron, all those are considered as the metals. Then carbonates. Or bicarbonates also given. Bicarbonates are also called as hydrogen carbonate. Hydrogen carbonate. Children, learn the valencies, ions. Once again I am stressing about that. Learn the valencies, ions and valence. Okay. And oxidation states. Now, bi means hydrogen should be there. So HCO3 is called bicarbonate. HCO3 is called bicarbonate. Whose bicarbonate? Metal bicarbonate. Take a metal. Sodium bicarbonate. sodium bicarbonate. So, or sodium hydrogen carbonate. Okay, there is common name for this. What do you call the sodium carbonate? CO3 means carbonate, HCO3 means bicarbonate or hydrogen carbonate. Whenever hydrogen is present, you consider the bicarbonate or hydrogen carbonate. Right. Sodium carbonate. Sodium carbonate is also called as washing soda. And what about this one? Sodium bicarbonate. It's about baking soda. Children, 4 types of sodas we learnt. 4 types of sodas. First one is drinking soda. H2CO3, carbonic acid, weak acid. Carbonic acid is weak acid. And another soda is NaOH, caustic soda. NaOH is called caustic soda. And H2CO3 is drinking soda. And sodium bicarbonate is baking soda. Remember here, when hydrogen is there, bi for bake, bicarbonate for baking. And carbonate is about washing soda. Understood? So 4 types of sodas are available now. Drinking soda, caustic soda, washing soda, baking soda. Right? Okay. Now let us see what happened to these carbonates and bicarbonates reaction with acids. So discussing the chemical properties of acids now. Now, what happened when this carbonate or bicarbonate of metals react with whom? Yes, acids. Children, remember the general equation is very crucial. General equation is very crucial. That's about metal carbonate. Metal carbonate or bicarbonate. Bicarbonate. What they are doing? They react with whom? Acids. Acids. Then what happened? That is our required. Okay, so when the metal carbonate or metal bicarbonate react with the acids, then immediately what happens? Salt will form. Okay, salt, and besides this, water, and finally the carbon dioxide gas is evolved. It is the general equation. Whatever the carbonate of metal is considered, whatever the bicarbonate of metal is going to react with acid, immediately one gas is evolved. Carbon dioxide gas is evolved. How can you prove that? With an activity. Okay, let us see. Activity means certainly we should go for aim, apparatus, procedure. Of course, the procedure is small diagram, and observation, conclusion, and the equation. All the things we have to be considered. Okay, let us see first. Aim. What is the aim? Based on the question you have to go for. Based on the question, show that carbon dioxide gas is evolved when metal carbonate or bicarbonate react with acid. Based on the question only, the aim will arise. What is that? To prove, what have to prove? To prove that CO2 gas is evolved. CO2 gas is evolved. So when it will happen? When carbonates or bicarbonates react with acids. That is our aim. What is the aim? To prove that carbon dioxide gas is evolved when carbonates or bicarbonates react with acids. Aim is over. Then what about apparatus? Apparatus we consider are instruments, chemicals. Okay, so here one boiling tube we need, and one test tube, and one chisel funnel, and one delivery tube, and 2-hole rubber stopper. 2-hole rubber stopper. Okay. So these are the requirements or the apparatus. And the chemicals. Let us see what are the chemicals that what we need. In the question itself, carbonates and bicarbonates and acids are given. Okay, you will take chemicals as the sodium carbonate or maybe sodium bicarbonate. Anyone? And acid, we take hydrochloric acid, and to test the carbon dioxide we need slaked lime, calcium hydroxide. These are the chemicals that what we require. Okay? Are you following, children? So what is the question? What happens when the carbonates or bicarbonates of metals react with acids? What happens? Salt, water and carbon dioxide will form. So the gas carbon dioxide is evolved. So what is our aim? We have to prove that carbon dioxide gas is evolved when metal carbonates and bicarbonates are react with acids. Okay. Right. For this procedure, what is the procedure we have to follow? Let us see. First, take a retard stand like this one. Retard stand I have to consider, and have to suspend a boiling tube. We have to be arranged. We have to fix. A boiling tube like this. A boiling tube is fixed with the help of like this, a holder. With the help of holder, it has fixed. Okay. Now take a few amount, generally 0.5 gram of anyone, sodium carbonate. May take sodium carbonate. It's about sodium carbonate. Okay. Now it should be closed with a 2-hole rubber stopper. 2-hole rubber stopper. Through one hole, we should insert one delivery tube. One delivery tube like this. One end of the delivery tube should be inside of the boiling tube. And one more hole is there now. With the help of this hole, have to insert one thistle funnel. Don't forget, it should be inserted so long, so depth of the boiling tube. Okay, so let us introduce a thistle funnel. Okay, so what is this chemical? Sodium carbonate. Now we have to suspend. What we do with the help of this holder, it has been fixed. Okay, the boiling tube is fixed with the help of a holder to the retard stand, and this boiling tube is closed with 2-hole rubber stopper. 2-hole rubber stopper. In one hole, we inserted one delivery tube. One end of the delivery tube. This is about delivery tube. One end of the delivery tube is inserted into the boiling tube. And one more hole is there, a 2-hole rubber stopper. In another hole, you have to insert thistle funnel. It's about thistle funnel. Okay, one important precaution you have to be considered that the other end of the thistle funnel should be very deep of the boiling tube. Very deep of the boiling tube. Now, other end of the delivery tube should be kept in another test tube. Already this test tube is consisting of calcium hydroxide, slaked lime solution. Okay, so it's about CaOH taken place, calcium hydroxide or slaked lime. Okay, so here one hole rubber stopper. With the help of the one hole rubber stopper, we have inserted this one like this. So let us see the arrangement once again. Take a retard stand and fix the boiling tube with the help of holder. And take some amount of sodium carbonate, most probably 0.5 gram of sodium carbonate in boiling tube, and close it with 2-hole rubber stopper. In one hole, insert delivery tube. One end of the delivery tube is a boiling tube. Okay, in another hole, insert thistle funnel. Okay, the one end of the thistle funnel should be very deep of the boiling tube. And arrange one test tube. What is this? Test tube. One test tube which is having calcium hydroxide should be inserted into the other end of the delivery tube. Okay, so it is about the arrangement. So after this arrangement, with the help of this thistle funnel, we have to insert hydrochloric acid, diluted hydrochloric acid has to be inserted dropwise until the tip of this one has to be this one. It is the tip of the thistle funnel. It should be dipped into the HCl. It should dip into the HCl. Okay. Now, after this, the reaction takes place between these two. Okay. Then, once the reaction takes place, then let us see what happens to this apparatus. Okay. It's about this activity. Now, this sodium carbonate react with HCl. Then what happened? One gas, a colorless gas is evolved, and that's the reason why I said the tip should be dipped into the HCl. If it is not dipped into the HCl, then what happened? What is the gas is evolved here that may escape through the thistle funnel? So the other end of the thistle funnel must be dipped in HCl. Then there is no chance of escaping of the gas through this thistle funnel. So then what happened? It must come through the delivery tube. And it will insert into the test tube. It will go or enter into the test tube which is having calcium hydroxide. Okay. So this is about procedure. Clear? Let us see once again procedure. Radar stand, holder, boiling tube, thistle funnel, delivery tube, 2-hole rubber stopper, other end is in the test tube, and the chemicals is about sodium carbonate, hydrochloric acid, and calcium hydroxide. Then, when the reaction takes place, then what is your observations? What is your observation? What is your observation? You observe that slate line. What is the other name of the calcium hydroxide? Slate line. Slightly, it converts into milky white layers. Milky white layer. Okay. So, why it is converting into milky white layer? Because we know the test of carbon dioxide. When the carbon dioxide is entered into the slate line, it converts into milky white. Milky white. Once the question is given like this, Zenith and Jeshwant, there is a communication between Zenith and Jeshwant that one gas converts slate line into milky white. That is the statement given by Zenith. To support that, Jeshwant quoted one more thing. That is, whitewash is the example for that one. Whitewash is the example for that one. Question is given like this: who is correct? Say who is correct? Your friend, so that you are supporting. No. Both are correct. Why? Because the direct content is given by the Zenith. What Zenith said? Carbon dioxide is convert the slate line into milky. That's correct. That is the content what we learned. What is the applicative part? That's Jeshwant said. Whitewash is the example. What is whitewash? Slate line only, no? Slate line is the whitewash. When you apply to the wall, atmospheric carbon dioxide will react that. Atmospheric carbon dioxide will react that and converts into layers. Okay, for the time pass purpose, somebody are going to do like that. The white flakes are going to be removed. That's the layers. That is also the same thing, the same reaction. So, don't forget the applicative questions also. The questions may be arising like that. Right. So what is the observation here? The slate line changes into milky white. Why it changes? Only carbon dioxide is having the property to change the slate line into milky white. So it's converted into milky white. It changes into milky white layer. Why it is converted like that? Because only the CO2 gas has the capacity to change slate line into milky. Okay, so that is what is the observation? The slate line changes into milky white layer. What is your conclusion? We know that, or we conclude that carbon dioxide changes slate line into milky white layer. Okay, so from this I conclude that the gas evolved is carbon dioxide when metal carbonate or bicarbonates are react with acid. We took only carbonate. If you consider about the bicarbonate also, we will have the same reactions. Understood? What is the final one? Equation. What is the equation? Write the equation like this. Sodium carbonate Na2CO3 plus hydrochloric acid HCl. That reaction takes place. Very easy to remember the equation. What are the things you all have? H2O and CO2. First you will write those two. Carbon dioxide is released, water is released. Now see the equation. Here H2O has got carbon, oxygen is gone. So CO3. Here carbon, 2 oxygens and 1. So carbonate is disappear. Hydrogen is present here. So hydrogen also disappear. What is there here? Sodium and chlorine. So NaCl will form. NaCl. See, 2 sodiums are there. Just keep 2 here. 2 chlorine. Now 2 chlorines are there. Just 1 chlorine. Just keep 2 here. Our equation is balanced. So it's about equation. Okay. If you have the sufficient time, go for the precautions also. Otherwise, better to stop here. Okay. What is the precaution? The other end of the thistle funnel should be dipped into the HCl. That is the precaution. Okay. So we have a brief look once again about this. Okay. So what is our question? What is our activity? Show that metal carbonates or bicarbonates react with acid to produce carbon dioxide or to liberate carbon dioxide. For that, what is our aim? To prove that carbon dioxide gas is evolved when metal carbonates or bicarbonates react with acids. For this apparatus we need a boiling tube we need, and a test tube we need, and a thistle funnel. This is the thistle funnel we need, and a delivery tube. This blue color delivery tube is needed. 2-hole rubber stopper. This one is a 2-hole rubber stopper. Okay, of course, besides this we are having retard stand also. Retard stand and bolt. Okay, otherwise here you have right, etc. These are the apparatus. And chemicals, sodium carbonate we need, HCl we need, calcium hydroxide, nothing but slate line we need. These are the chemicals we require. Procedure: fix the boiling tube with the help of holder to the retard stand and take some amount of sodium carbonate in the boiling tube and insert delivery tube through one hole of the 2-hole rubber stopper which is fixed to the boiling tube, and in another hole insert thistle funnel. The other end of the delivery tube should be in test tube which is having calcium hydroxide slate line. Now that's about the procedure and arrangement. Now when you add some hydrochloric acid to this one with the help of thistle funnel, reaction takes place between this HCl and sodium carbonate and one gas is evolved. It won't escape to thistle funnel because it is already inserted in HCl, so that it will come to this delivery tube and enter into the calcium hydroxide. Okay. That is the things. Then you have to observe one thing. If you observe what is happening here, this straight line converts into milky white layer. That is our observation. Conclusion. What is the conclusion? Only carbon dioxide gas has the capacity to convert the straight line into milky white layer. So from this, I conclude that carbon dioxide gas is evolved when bicarbonates or carbonates react with metals. The equation Na2CO3 HCl gives rise to NaCl and water carbonates. While you are writing this equation, general equation is important. These two are common. H2O CO2 is common. So write H2O CO2 directly. Okay, when you write the H2O and CO2, the rest of the salt we can identify what is the salt that is going to be present here. Okay, so like that you can write different equations. You may take sodium bicarbonate, sulfuric acid, and magnesium carbonate with nitric acid. So carbonate bicarbonate and acid. Carbonate to bicarbonate of metal and acid. Whatever the acid that you may take, right? Like this 2 or 3 equations, not this one. Okay, other 2 or 3 equations, then you can analyze the content and the concept, how it is coming. Clear? So what is the final one? Equation. Okay, ma? I think you understood. Now, let us see one more indicator, that is about olfactory indicators. Why again olfactory indicators are? So many indicators are there. Red litmus is there, blue litmus is there, methyl orange is there, phenolphthalein is there. Why again? One more indicator. Of course, 2 more indicators. Universal indicators also there, that is separately we will learn. Olfactory indicators. Before going to that, I want to instruct one thing. Commonly, most of the children will learn like this: red litmus, blue litmus, methyl orange, phenolphthalein. But the question may be given: first red litmus, blue litmus, third phenolphthalein, fourth red litmus. But the children doesn't observe what the question is given. Directly first they will see red litmus, blue litmus. I know the question, so directly they will answer what they are understood. Okay, so they are committing the mistake. And what they said, all correct way, they clap. But once after the correction, it went wrong. Why? Because they are not observing the question. Observe the question. Okay, so read the question properly, observe the question and how it is given and where you have to be answered and how it have to be answered. So remember, read the question properly and observe what are the contents that has given, what is our requirement, means what is asked. Okay, right. Let us see the olfactory indicators. Okay. Olfactory indicators. Let us see how we can create this olfactory indicators. Very easy process to create the olfactory indicators. And why? What is the necessity of creating the olfactory indicators? Once in NTSC the question is given like this. Deepika Sen is having one friend called Monica Chawla who is blind. Who is blind. Then now she wants to identify the bases and acids. What is the nature? If you see methyl orange, phenolphthalein, pink is color, red is color, she is blind now, she can't observe. To overcome such problems, olfactory indicators has been introduced. Olfactory indicators, what they will do? They will change the order, smell. They will change the order and smell of the particular indicators. Okay, so which are the olfactory indicators? Let us see. I understood, in corporate examination is given. So olfactory indicators are useful to identify the indicators even blind also. Okay. Right. So olfactory indicators means the indicators which change their order or smell, which change their order or smell in the presence of acidic medium or maybe basic medium. Now, what are the things that having olfactory indicators about onions, vanilla essence, and clove oil? Commonly these are going to be considered as olfactory indicators. Let us see how we can prepare olfactory indicators. Okay, with a small activity we can go for that. Okay. Okay, children. Let us see how we can create these olfactory indicators. So first, aim. What is our aim? To create. What we have to create? Olfactory indicators. For this, what are the instruments we need? Instruments or tools or apparatus we need. Let us see what are the apparatus we need. One, polythene. Don't forget, children, it is a high density polythene. You may see, I am not using the polythene which is not need to be recycled. It is a recycling polythene. Okay, don't misunderstand. And a clean cloth, onion, and knife. These are the apparatus. Okay, then procedure. Let us see the procedure. What we have to do and what are the things happen. First, you have to cut this onion into small pieces. It has to be cut into small pieces. Okay, so like this, it has to be chopped into small pieces. These coronavirus are helpful to me. How to cut onions and etc. Okay. Now, onion pieces has chopped into 5 pieces. They have been cut into small pieces. Now, after cutting into the small pieces, these are the onion pieces, small onion pieces. Just see its smell. You know, onion smell. Now, finely chopped onion pieces has taken in a clean cloth. Okay, so in a clean cloth, I am going to take all these onions. Okay, right, and close it tightly. Close it tightly and keep in a polythene cover, and you should get in a fridge over a night. Okay, so today I chopped into pieces. Today I am going to insert in fridge, and tomorrow we will see what happens. You know the smell of the onion. Tomorrow I will take the same onion pieces and I will add some acid or base on these chopped onion pieces. You can observe that the smell has changed. So from this we can identify whether it is a acid or base. Similarly, we may take the remaining also, vanilla essence. Okay, so it's about vanilla essence. Okay, so it will also change its odor, smell. Okay, now it's giving the very nice smell. After that, it's going to. Now, clove oil. Clove oil is not available in the market at present, so I brought only clove. Okay, so clove oil. From this hot oil. Okay. So these are called olfactory indicators. What is by olfactory indicators? Which change the odor, smell. Okay. So I think you've understood how to create the olfactory indicators. Very easy process. First take an onion and chop it into several pieces, and they should be kept in a clean cloth and have to be inserted in a polythene paper. It should be kept over a night in fridge, and of course tomorrow again I will get it. And what's happened to the smell, because you may not sense. Okay, just sense. I think you can understand. Okay, tomorrow will come with otherwise. And today what we discussed? Some chemical properties about acids react with carbonates and metal carbonates. Children, you have to practice 2 or 3 equations. And don't forget, tomorrow everyone should have the textbooks, and we are going to underline the keywords, and we have to insert some more examples in it. Okay. Then olfactory, creating of olfactory indicators. And one more important thing we discussed, that bases will also react with whom? Metals. But not all the bases. Only few bases will react. That too on heating. But acids directly react with metals, which is an exothermic reaction. It is released. Here we are heating when the bases are reacting with metals. Such kind of differences and comparisons are very important to memorize for a long time. Have a good day. Thank you.